We are going to revisit some old friends here, a NAT and PAT refresher. Let me move that just a moment. There we go. And just a quick refresher on what NAT does to begin with and why we use it. Network address translation allows a network host with a private IP address to have that source IP address of their packets translated, if you will, into a routable address. And the router, our NAT router, is going to keep track of what private addresses are translated to which public addresses, so when the packets come back they can be routed successfully. That's called a NAT translation table that the router keeps. Now, just walking through a quick example here, we've got Bob and Dan here on an inside network. We know by looking at these addresses of 10111 and 10112 that those are on a private address range. Well, that's fine as long as they're talking to other hosts on our private network. But when they want to talk to somebody outside the network, we've got a problem because those addresses aren't routable. And here, let's say Bob sends packets sourced from 10111 here. Well, when they get to the server and then they come back, the server wants to respond, then that source address becomes the destination address. And it says, wait a minute, I don't know what's going on here, but I can't even route these. They're not even going to go out. And that's why in all of our firewalls that we've seen so far, the default configuration includes banning packets sourced from the A, B, and C private address ranges because they're not supposed to be coming in anyway. So NAT allows us to get around that. And the only problem here is that while we can create what we call a pool of routable addresses, that can be a bit of a problem because we're only going to have so many routable addresses sitting around for use like this, right? So it would be great if we had a way to use a single routable IP address, and even better if it could be one that we're already using in another way. And that's where port address translation comes in. Port address translation, PAT, allows a single routable address to be used by multiple inside private hosts. Now, the private IP addresses are translated to the same public IP address, but each host is going to use a different port number. And even better, that single public IP address is going to be the address that we're already using on the outside interface of this router. So that works out really well. PAT is commonly referred to as overloading, and at the command line, it's actually the word overload that enables PAT. So that's where the term overloading comes from. So overall, it's a straightforward process. And what I want to do is show you some of the options for this in CCP. So let's go ahead and pull CCP up here. I know I need to redo that. There we go. And all I've done here, I've already rediscovered the router, etc. And you can see where we are. I hit configure and then router and then NAT is under here. And we've got two options for it, basic and advanced. Let's take a moment to look at this. Now, I mentioned Cisco CP can guide you through NAT configuration tasks, which of course is why we're here. NAT allows you to connect the hosts on your LAN to the internet, select a task, and then just hit launch the selected task. Well, basic NAT, if you just have PCs or hosts on the LAN that need access to the internet, select this option. And we can see with the illustration that we've got PCs on the inside. It even mentions PCs with private IP addresses. Here's the router, here's the internet. Let's click Advanced NAT and see how things change. If you're hosting servers, e.g. web servers, email servers, that users outside your network need access to, you select this option. I'm glad they told us about web servers and email servers and that those are actually servers. So let's go ahead and hit Basic NAT and we'll click Launch the selected task. And it mentions to connect the PCs and hosts to the internet, you must perform these tasks. First off, you got to choose the interface connected to the internet or to your ISP, and choose the networks on the LAN that are to share the internet connection. Because if you have several inside networks, you may be in a situation where you don't want all of your inside hosts to be able to go out on the internet. So let's go ahead and click Next. First thing we have to do is choose our outside interface, the one that connects to the internet or your ISP. In this scenario, I'm going to pick Fast Ethernet 01. We've been using that for the outside and we'll continue to do so. Now it mentions the following ranges of IP addresses are allocated to networks directly connected to the router. Check the box next to each network that is to share the connection that you specified. So let's say that I pick the address range 210.110 to 210.112.55, which is connected through fast Ethernet 01. And I just hit next. Well, you're going to get an immediate error message, a warning. You cannot choose the same interface, fast Ethernet 01, as your internet connection, as well as the interface, the IP address range, which is to share the internet connection. So it's saying, hey, that's not what we're here for anyway. This is what we'd want to do, is select our 10.110 to 10.112.55 network. And you just hit next. And really, this is connected to the internet or to your ISP, fast Ethernet 01. It gives you your address ranges that are to share the internet connection. And I'm going to hit finish, and I'm not going to deliver this one because I want us to go ahead and go back and look at the advanced wizard now. Again, commands you should be familiar with. And what I'll do, actually, hold on for 1 second, because we need to go over that. I want to look at that. It used to narc on you and say, hey, this config came from, Brian Advantage, blah, blah, blah. It's like, fine. It's my config. I'll do what I want. So let's go ahead and just take a look at this. This is the config that was about to be delivered. We remember this from our NA studies. You've got to identify the inside networks that can use NAT with an ACL. And those of you who got your NA with me, you know these two commands. I hammer these home because they're so easy to forget. You do have to identify your inside networks, and you can have more than one, your inside interfaces, and then your outside interface. And here's that one long-winded command, IPNet inside source list 1, referring to access list 1. And our interface to use is interface fast Ethernet 01, and there's that word overload. So we're using port address translation right here. So let's go ahead and bring that config back up, and I'm going to go ahead and cancel that. But you can see how quickly that will put together a NAT config for you. This is edit NAT configuration. That's going to come up after you run your NAT config. But since we didn't deliver anything, we don't have anything to edit. Let's take a look at the options with advanced NAT. And it just mentions, use this wizard if you need to allow both users from your LAN to access the internet and users outside the LAN to connect to web servers, email servers, or other servers on your network. And let's go through the steps for this one. Now it's going to ask you to specify the interface that currently connects to the internet, and that's 01 for us. You can then add public IP addresses that you may have purchased from your ISP for servers that may share this internet connection. So if that were the case, you could just click add here and start adding them in. I'm not going to do that. And this looks familiar. We need to identify the networks in the LAN that need access to the internet. These can be networks directly connected to the router or networks that the router is connected to through other routers. So we could add some networks here if we needed to. Here's IP address and subnet mask. I'm just going to add the same one and hit next. And here's a big one. Specify public IP addresses for servers. Users outside your network who want to access servers on your LAN cannot do so because those servers have private IP addresses. You must provide access by creating network address translation rules that associate public IP addresses, which outside users can use, with the private IP addresses of the servers. So if we're going to add a rule to that, we'll just pull one out of the hat. You can see it's got a private address and then a public IP address. So let's see, if we had a private IP address and a server of 151, and if we were going to say public IP address, we're going to use the IP address of fast Ethernet 01 for that. Then it's even going to ask you what type of server it is. Is it a web server, email server, or other? And if the web server, which I picked, is using a non-standard port internally, you need to select that port number here. Email server, it's going to be the exact same thing. What happens if you select other? Specify the port used by the server internally and the port outside users will connect to, and you even get to check the protocol. So let's say it's a web server, and I'm just going to leave it at the original port. We all know what that is. And there we've created a simple mapping. And let's see, before we hit finish, it's going to tell you the interface connected to the internet. the address ranges that share that connection, and your NAT rules for servers. So let's see what that config is going to look like. A lot of course, is going to look very familiar. Let's go ahead and bring that up. I thought I could get away with that, but I didn't. And here's the second one we wrote. And a lot of this, of course, looks familiar, except for this mapping that we made. IPNAT inside source static. And it's TCP. It gives the inside IP address and port. And then what we're doing is using the IP address of Internet Fast Ethernet 01 as the outside address and port 80. And hence the command IPNAT inside source list 1 interface fast Ethernet 01/overload. And that's really it. Not a difficult config at all with CCP or at the command line. You learn how to do that in your CCNA studies. And we'll just go ahead and deliver that. But again, not a major topic, I would think, for your CCNA security exam, but still an important one to know. And I wanted you to see this. Now, of course, the big question is, well, this is all great, but outside of a review of NAT and PAT, what's this got to do with security? Well, we are in the firewall section. And remember when I mentioned a long time ago that sometimes when you're doing things like creating VLANs, you know, that, said it couldn't be copied to the start. Okay, so we've got it there. That's fine. I'll fix that later. Remember when I mentioned that sometimes we do things like, you know, just putting hosts in different VLANs and we're actually creating a firewall between the hosts even though we don't really think of it that way? Well, that's really what network address translation does for us in a way. It's a security feature because what you're doing is masking the inside networks that you're using. Because, you know, we do tend to use the same ones over and over in different sites. But part of that recon attack that I've talked about in a couple different parts in the course, it's an information gathering attack. And some network attacks become a lot easier when I know what your internal network numbers are. So NAT is a way to fog that. It's a way to disguise it and say, hey, we're just using these routable addresses and we're not going to let anybody outside the network know what our internal network numbers are. So it's just another part of security as well as getting around some address allocation problems. That is about it for NAT and PAT for now. So let's go ahead and head to the next video.